Welcome to Calculated Indicators in AssetWise IVAR Performance Management. By the end of this unit, you will understand what a calculated indicator is, how to create a calculated indicator, how to trigger a calculation, and some of the basic syntax, functions, and expressions available for use in calculations. So what is a calculated indicator? We know that indicators are indications of asset health. In some cases, we cannot measure asset health directly. We must compare or manipulate data from one or more sources in order to determine the condition of a complex system. Calculated indicators are the tool we use to do this in APM. Calculated indicators can mine data from other indicators or from other objects within the database, and can perform mathematical or logical operations on that data to output a reading in a defined format. So in essence, a calculated indicator is an indicator that manipulates data found in the database and outputs a value automatically in the format that is needed. Otherwise, the object behaves just like any other indicator. The best way to understand calculated indicators is to describe a scenario where one is needed and to demonstrate how it is built. For example, we wish to calculate the fuel efficiency of a vehicle. There is no gauge on the vehicle that directly measures and displays the vehicle's efficiency. However, we can record the vehicle's mileage and record how much fuel was consumed over a given period of time as numeric indicators. We can then use that information to calculate the efficiency of the vehicle over a period of time. To review the existing indicators on an asset, first go to the Indicators view. Next, navigate the asset hierarchy to select the asset to measure the fuel efficiency for. In this case, we'll use Haul Truck 871. When we highlight the asset, we can see the list of indicators already existing for that asset. In this case, we have both an odometer reading and a fuel added reading. If we open up the odometer reading, we can see that the counter and unit of measure that we're using is in miles. And if we open up the fuel added reading, we can see that the measure is in US gallons. Now that we know what's available to us, we can determine the calculation that we need to calculate fuel consumption, where fuel efficiency equals the miles driven since fuel up divided by the gallons added at fuel up. Let's assume that fuel up occurs at the end of every day and that the driver doesn't run out of fuel during the day. Now that we know our calculation, we need to determine the output unit of measure. In this case, we'll use MPG, or miles per US gallon. Now that we know our equation, we can go ahead and create the calculated indicator. With the appropriate asset selected, click on the New button in the lower right of the Indicators view to create our new indicator. Next, we'll select From Scratch to create a brand new indicator, and click OK. Within our new indicator, we have to give it an appropriate name. This name must follow the naming convention. The Bentley naming convention is to be concise, not use abbreviations, and to write out the name in title case. In this case, fuel efficiency. Next, we'll select an indicator type. In our case here, it's a calculation with an output of miles per gallon. Lastly, we'll change the collection method from manually entered to calculated using a formula. Note that this opens up the Calculation tab. From the Calculation tab, click in the Calculation field. This is the field where we write out our equation. The Calculation field follows VB script syntax and is limited to 32,000 characters. Let's recall our original equation, which is fuel efficiency equals miles driven since fuel up divided by gallons added at fuel up. The calculated indicator that we are creating is our output, fuel efficiency. So we only need to include the right side of our equation in the calculation field. Because of VB script syntax, we need to remove the spaces in our names of our inputs. The convention is also to shorten the names to one word and expand the name in the field provided, which we'll see in a moment. For now, let's just enter the equation miles divided by fuel. Once we've entered our calculation, we should save our progress. APM is warning us that we have variables defined in our equation that haven't been defined as inputs in our indicator. Let's just click yes for now, and we'll save our progress. Now we need to define input variables. Click on the down arrow beside the New button in the bottom right of the screen, and select Indicator Input. In the dialog that opens, enter the input name exactly as it appears in the calculation field, and enter a more detailed description of the indicator input in the description field. As you had already selected an asset to create the calculated indicator against, the dialog window will first look for indicators to assign to that input from that asset. In our case, let's click on the Indicator to Use field and select odometer, as that is the source of our mileage reading. Lastly, we can select to either use a single reading, the last reading only, or an aggregate of a number of readings to use in our calculation, say the average of the last 10 readings, or an average of the readings taken this month. Should you choose to use an aggregate of a number of readings, you will also have to select an aggregation type from the Attributes Info tab. However, for this particular calculation, we are only interested in the most recent reading, so we do not need to choose an aggregation type, and we can just select the last reading only. Lastly, you can enter a test value to test the logic of our calculation expression from the Test Value tab. In this case, we'll enter 250 miles. Then click on the OK button to complete our input. Next, we must repeat this process for the other input, fuel. So again, click on the pull down next to the New button and click on Indicator Input. Enter a name for our input and a long description. And select an indicator. And again, we'll select the last reading only and enter a test value. And then we'll click OK. Once we've defined our calculation and set the inputs, we need to define the required proximity of those inputs. This is needed to ensure that the values that we are calculating with are of a valid time period in relation to each other to give us an accurate measure. In this case, let's assume that the odometer readings and the fuel added are done at the end of the shift. So if we make the proximity of the inputs as being within 20 minutes of each other, the results should be valid. This is done at the bottom of the screen. Next, we should save our progress. Next, we need to set the trigger for the calculation. This is done from the Frequency tab. By default, the trigger is set to run whenever a new reading is entered for one of the inputs. We can also change the trigger to occur at a regular interval based on a recurrence pattern. This is typically done when either of the inputs uses aggregating, such as taking the average of multiple readings for one of the inputs, or the trigger is only required to occur at a regular set interval. For now, we'll just choose to trigger the calculation whenever a new reading is entered on one of the inputs. and then we'll save our progress. Once the trigger is set, the calculated indicator is complete and will trigger based on the rule we've selected. You can, however, choose to trigger the calculation manually. This is done by clicking Calculate or Recalculate. These are found in various locations, such as the Frequency tab that we're on now, this Recalculate Now button, or from the Tools menu, we can click on Calculate here. You can also find Calculate in various tables where an indicator is found. Calculated indicators are highly versatile and can be used to manipulate data of different forms, numeric or descriptive. Because it follows VB script syntax, this allows for logic functions, if then else statements, and or not logic, for, to, or counting loops, among other things, to be used. This screenshot shows an example of the level of complexity the calculation can entail. Calculated indicators are not only used to output numeric readings, they can also be used to output descriptive indicator states, as seen in the screenshot here. Bentley Systems Inc. has several examples of complex calculated indicators used in various different operations. These examples can be made available upon request. Thank you for watching this video. By completing this unit, you should know what a calculated indicator is and can be used for, know how to create a calculated indicator, defining the indicator properties, entering the calculation using the proper VB script syntax, define the input indicators as variables in the calculation, set the required proximity of inputs, check the validity of the calculation, and set the frequency rules for triggering of the calculation. And you should also know some of the basic syntax, functions, and expressions available for use in a calculated indicator. For more information on the types of calculations possible and the proper syntax to use, search for calculated indicators in the Bentley APM help file.